All right, so today we're in for a treat. We have Michele Catasta, VP of AI at Replit, which is a, I guess we'll get into it more, but it's a platform that's very popular with developers because it allows them to build software collaboratively with AI on any device without spending a second on setup. And quick note, he will be speaking at the AI conference in San Francisco, September 26 to 27. This is in person, so this is your chance to meet him in person. Go to aiconference.com for details. I'm the program chair, and it will be an outstanding conference. So welcome to the Data Exchange podcast.
Hi, Ben. Thanks for having me. Very excited to chat about AI with you today.
All right. So Replit comes from, I guess, the acronym REPL, which a lot of developers know, right? So read, eval, print, loop.
Correct.
An interactive shell. We'll talk about more broadly the topic of the role of AI and generative AI in programming and software engineering. But very briefly, what exactly does Replit offer, and who are the target personas?
All right. Replit offers, I would say, a platform to develop software, and it really gives you the shortest path from having an idea to deploying a minimum viable product. And I would say the target population is everyone in the world. That's the reason why we say that Replit is going to empower the next billion software developer. Replit has been conceived to lower the barrier of entry to programming and make sure that everyone can become a software developer.
So as many people know who program or write code, there's two aspects of it, right? So one is the obvious, you write code, so you must know some programming language. But the other kind of aspect that most developers know about and take pains to avoid is kind of the tools and the setup. And once you have your laptop set up, you're kind of attached to that laptop and you don't want to let it go. So I'm assuming that Replit helps me with both, right?
Absolutely. So Replit doesn't have any setup time. You log in, you click in your REPL, and at that point, you're assigned to a container that has access to all the dependencies in the world across every single programming language you can think of. They're just one click away, and the environment is ready to go. You start to run your first line of code. When it's ready, you click run, and that's the REPL aspect. You can run your code continuously and see if it works or not. And one cool feature that we started to announce and is going to become much better in the weeks to follow is that we have support for deployments, one-click deployment. So when your app is ready, you deploy it on the cloud, and it scales with the amount of traffic that it receives. This sounds like science fiction for, I would say, the two of us who have been in tech for many years, and before that required a lot of effort from engineers. So not only in writing code, but in doing all the setup and all the deployment. And we're really making that experience as delightful as possible at Replit.
And as many people know, when you're writing software inside a company, you obviously don't do that in isolation. You work with other people, other developers, other engineers, maybe PMs. But more importantly, you probably also need to interact with systems other than your own. So you may have to get data from this place or deploy over in that place. So how does Replit fit into kind of the, I guess, a developer who's part of a larger team?
Okay, so I would say from the point of view of how to collaborate with other humans, we support several different paradigms. The most common one is version control. We have our own front end for Git, which makes it way easier to use. But then at the same time, we have multiplayer support, which is literally bringing the, say, Google Doc or Figma experience to software development. You can invite your friends, your colleagues to work on the same REPL, and you edit in parallel the same file. So this is for the human factor in terms of collaboration. Then, as you said, software always lives within an ecosystem of different services and different platforms. And when you join Replit, you don't only get access to your editor, but you also get access to a lot of different components that you can add to your pipeline. You can have a database, you can access APIs, and over time, we're going to be offering more and more connectors to cloud services that will allow you to basically scale up your application and make it as powerful as many of the big products that you can use out there today. So that is our long-term vision for Replit.
So as I understand it, the company started before this generative AI craze.
By all means, yeah.
And obviously, you've had to kind of take into account how much more powerful some of these generative AI models and LLMs are. As someone who was one of the early paying users of GitHub Copilot, I was already kind of happy with what GitHub Pilot was doing for me, but now it seems like it's a different level. So I guess based on what you've described so far, obviously any kind of AI or coding assistance is just a subset of what you do. But how important of a subset has it become among your users and among prospective people who are kind of evaluating the platform? So is this now kind of like where people make decisions, right? So how good is the AI of this software development platform?
I think that more and more AI is going to become fundamental in the process of software development. We already know that our users love the features that we're building on Replit with AI. I wouldn't say that they are necessary. We've been writing software in this way for many, many years. I do think that, and I talked with several people who have been expert software developers for decades, and they still love to have Copilot, they still love to have Ghostwriter on Replit. It's tangible, the fact that they make you more efficient as a developer. And our job as software developers is to be as lazy as possible. Like, we all like that. So that's what AI is enabling us to do. On the other hand, the reason why, as a company, we're excited about AI is not only for the present, but I would say is much more for the future. As in, AI really lowers the barrier of entry. It makes software development less scary for a lot of people. Because especially now that we have these chat interfaces that allow you to have a conversation and do several different iterations to converge towards what you really need. This has put software development in the hands of people that have good communication skills, have perhaps a product idea, have been hacking just a little with Python before, and the AI is holding their hands through the development process. And that really allows you to go from an idea to a hack in a couple of hours. The kind of dopamine hit that you get from that satisfaction is very much addicting for people that are creative. And we see this when we arrange hackathons, for example, at the office. And we bring people that are very young or people that have a PM background, and they love to see that they can actually build software. So that's what personally I'm excited about when it comes to AI applied to software development.
Honestly, for me, it's one thing. Okay, so it suggests code and you look at it. So for me, it's one thing for it to suggest code or suggest really great autocompletes, and that's great because you take that code and you look at it, and it's not like you're gonna accept it without looking at it carefully, right? So, but to me, what's really been surprising is its ability to take error messages and basically make your life less painful from that perspective, right? So you can say, so this is what I'm trying to do. Here's the error message, and then the suggestions tend to be quite good. So, quick question for you, for those of us who aren't deep into the models that are being used for AI for software development. Is there a big difference between these different models? In other words, so some people might go to Bard or Anthropic or GitHub Copilot or your own model. So at this point, do you think there's a substantial difference from model to model as far as the AI for coding itself?
I would say there is definitely a difference between models, perhaps not between pairs of specific models, and I'm going to elaborate about that. It's more about the family model that we take into account. So Copilot or the code completion model that we train at Replit, the Replit Code V13B, those are models mostly focused on code completion or code generation. And then there's another class of models that are powering ChatGPT 3.5 and 4, Bard, the different code from Anthropic. They serve a very similar purpose. Then depending on how powerful and usually how large the model is, you will see them behaving better, especially on harder programming tasks. So these are, I would say, the two main categories that we use today. And at Replit as well, we use, we have the code completion feature, which is served and built around a specific model. And then our Ghostwriter chat, which is powered by like several chat models, but they're all part of the same class.
So should we think of these models for coding and programming very similarly to just general LLMs in the following sense, right? So, there's the general LLM, then there's the custom LLM, there's fine tuning, there's retrieval augmented generation. So everything that applies to an LLM applies to an LLM that's specifically for coding.
Absolutely. Absolutely. So even the more generic LLMs in the past, I would say year and a half at least, everyone agrees that training them further with code makes them smarter. LLMs trained on code gain better reasoning capabilities. And of course, they also become better at generating code. So the GPT 3.5 and 4 of the world, they've all been trained on substantial amounts of code, and Bard is the same. The interesting reason why the retrieval augmented generation is still a technique that applies even to the most powerful model out there is because it allows you to overcome the information cutoff problem. So namely the fact that models have been trained up to a certain date in their training data set. But then if you want to be able to generate code on the latest and coolest library that appear on GitHub, the only way to make that happen is by adding the context in the prompt some information coming from the library. So we do that on Ghostwriter Chat. You can do that manually if you use ChatGPT by include code coming from a library that it hasn't been trained on. And yeah, at this point, I would say these are common techniques that apply to every large chat model that is available out there.
So the stereotype for LLMs, the general purpose is they're trained on kind of internet data, and internet data is messy, right? So think of Reddit and all sorts of sources, right? So for training models for programming, does everyone end up in the same place? So in this case, GitHub, or what are some of the key data sources for training these models? I suppose you folks, for example, have your own data sets because you've had many years of working with developers, right?
Absolutely. I would say, of course, GitHub is a gold mine of useful data for coding, and it's one of the largest data sets that is available out there. Shout out to the Big Code project led by Hugging Face and other companies that released the DStack dataset, which is a collection of permissively licensed data coming from GitHub. And that's a dataset used by us and by other organizations to train models of code. So there is a good starting point in that dataset. But then definitely at Replit, we have our own code base and all the public repos that are released under MIT license. We use them to further fine-tune our code completion model, and we saw substantial performance improvement up to 40%. So that's a data set that we're going to keep using to tailor our models towards what the Replit users write software on a daily basis. So these are definitely data sets of data sets of source code are very important. But as you said, there are other sources out there that contain a lot of interesting information. Reddit is definitely one of them. I'm very excited to see a future where we're going to be capable of using Discord. As you know, a lot of the AI, discourse is happening on that platform. So there are, in a sense, the LLM race is not that much about figuring out the next best architecture to train models, but it's really where do we find the best and highest quality data on a specific task. And for the case of our discussion is where are software developers and hackers writing content. So not only Stack Overflow anymore, you might have seen that their traffic is plunging. So we need to find alternative sources of that data.
And to our listeners who may have missed a recent survey for Stack Overflow, the numbers are just insane in terms of the acceptance of AI assistants among developers of all levels of experience, right? Of all levels of experience. Everyone is open to it, which makes sense, right? So like you said, developers inherently lazy, so they're open to anything that can make them more productive.
I love that survey because I often get the pushback that AI is only going to help people that are just getting started or that they learn how to write code only in recent years. But it turns out that more and more these features are getting in the hands of people from any walk of life and every level of expertise. It's fascinating to see how powerful these models are. So and the few times that they help you, at that point they really become part of your daily routine. And I still use these models 24/7, not only because I'm developing them, but because it's fascinating to see what they recommend to you while you're writing software. There is always something to learn, even if you end up not using the code that Copilot or Ghostwriter recommends to you. A lot of times I'm learning out of the responses that I'm getting.
And so are all these models kind of they all are correlated in the following sense? They all tend to be strong in the same area. So everyone is strong in Python, JavaScript, less strong in some of the less, because it's data dependent, right? So how much data do I have? So the more popular programming languages, these models tend to be stronger. The less popular programming languages are weaker. Is that a fair assessment?
Yeah, you're spot on, of course. Like that's the reason why we see a lot of examples in Python. A lot of demos are in Python. These models appear to be the best on programming languages for which we find the most amount of data out there. So this is unavoidable. One silver lining is the fact that very large models tend to do better on low resource languages because there is some level of transfer learning between language that has a lot of resources and then the long tail, say Rust. I mean, I don't want Rust people to get offended. I think it's an amazing language. It's a great community, but of course, there is much less Rust code on GitHub and Replit compared to Python. And I say this because we have a lot of vocal Rust users on Replit as well, and they will love the models to be more powerful, but there is so much that can be done when there is not enough data out there. That's the one fundamental limitation of LLMs. And I see some interesting research techniques that are gonna pay off. I strongly believe in syntactic data generation. So the moment we're gonna be able to create big synthetic data sets for low resource languages, I think that's gonna allow us to fill this gap very quickly. And I'm excited to see what the AI community is doing research on right now.
So let me put you on the spot. Let's do a thought experiment. Let's say all of this technology existed in 1999 and midnight we have Y2K. So there's not a lot of Fortran out there.
Ouch.
Will these tools have helped us through the Y2K dilemma?
All right. Of course, that's a hard question, but I'll try to give a realistic answer here. I see models, again, especially the large ones, doing pretty well when it comes to code transformation, where you can explain in English what you want, and then the model follows your instructions. And this is what is called in the field instruction tuning, where you have a very detailed and well-structured English explanation, and then you provide several different examples on how to make that code transformation. So I think with the awareness that we have today on how to train these models, we would have done a pretty decent job at that. The big caveat here, and if I would be intellectually dishonest if I didn't mention it, none of these solutions are guaranteed to be 100% correct. So the Y2K bug was so scary because it could have affected anything at the level of infrastructure and grid and banks and so forth. I would have still recommended to have a lot of humans in the loop to make sure that each single code transformation was vetted by a human. But I do think that it would have allowed us to go through that period in a much faster way. Like we would have been able to transform large code bases faster than it actually happened.
So let me ask you about code quality, right? So which is basically, I guess, kind of a proxy for the effectiveness of these tools. Because if a lot of the training data is from GitHub, and GitHub, is like Reddit of coding, right? So it would be great if all of GitHub is populated by the code of Sanjay Gemawat and Jeff Dean, for example, right? So how do we? I mean, so how will the community improve code quality so that what is it? So what is kind of what is the rule of thumb, right? So a very good programmer is 100x better than an average programmer. So how do we get to the point where the quality being produced by these tools is orders of magnitude better than an average programmer?
So this is a great question, and it's probably one of the questions that keeps me up at night in the past few years, because that's exactly the field where I've been working on. I will try to give several different hints on how I think we could tackle this problem, but by far it's an open research challenge. Otherwise, we would have a model today that only generates super high quality code, which is not the case. So that being said, definitely one way to attack the problem is to filter the code on which we train such models. I know that from the outside world, it looks like LLM follow this kitchen sink approach, where you just hoard as much data as possible, throw it into the training loop, and hope that something amazing is going to come out with the output. It's not actually the case.
What is it? The chinchilla paper, there's a level of saturation that you need to achieve.
Yeah, so the chinchilla paper shows you it's worth to train on much more data than we were actually doing before.
Right.
And even more interesting, the Llama family, both Llama and Llama 2, they show that can be brought to an even further extreme. So this is crazy, like between the, say, 2021 LLMs, the late 2021s, and what we have today, we went up at least 100x in terms of how much data we believe is useful to train on. So now we're on the order of 200 plus tokens per parameter in an LLM. And that turns into a big problem because we don't have enough data to train them on. So one will be tempted in saying, let me collect as much as I can find and just train on the data. It turns out that instead it's better to still apply a certain level of quality filtering, both on natural language and on code, and rather train perhaps on a few epochs. So allowing the model to see the same code a few times rather than allowing it to train on a lot of low quality data. So that's one that's one trick, that at this point we know pays off. The other one is
then you need a panel of human experts to filter for high quality code.
A panel of human expert is one way, but it's a very expensive and non-scalable way.
The most expensive people are the people that you want to filter the code, right? So.
Exactly. So one way we do it today is by using large models that are way expensive to tag, to label the data samples.
As a classifier, kind of.
Correct. So if you have infinite credits that you want to use on GPT-4, a great way to filter the quality of your data is by using GPT-4 to do that. So in a sense, we are seeing this phenomenon where the next LLM is being bootstrapped by the previous generation. So most likely the GPT-5 will be bootstrapped by doing a lot of quality filtering based on GPT-4.
Neuroevolution applied to LLMs. What about?
I think no revolution applies in AI.
No.
Yeah.
I'm just kidding. I'm just kidding. What about synthetic data?
So the exciting thing about synthetic data is when we find a way to generate it that retains is above a certain quality bar, then we sort of found a holy grail for LLMs. I don't think we're there yet. I see that paying off for much smaller data sets. So we're seeing techniques where people generate synthetic data for instruction tuning to allow it maybe to do a 5x or a 10x on the original dataset size. I don't think we still have the technique that allows us to do proper synthetic data generation at the scale required by a pre-trained LLM. And of course, I think that's sort of a tautology, because how can you regenerate synthetically the whole internet? So
Right.
that the importance of the pre-training data set used by a base model is the fact that it contains a lot of the knowledge that mankind has today. You can't really synthesize that. But yeah, we know that instruction tuning is extremely powerful and pays off. So even being able to up the quality and the amount of instruction tuning data through synthetic data generation, that is something that we're very bullish about in the community.
So for non-code, so text, video, audio, that kind of thing, there's at least some kind of proxy for quality. You can look at Amazon book reviews or I don't know, Rotten Tomatoes kind of scores and stuff. So for code, I guess GitHub stars, but that can be gamed. Programming Olympiads, but the questions are kind of concocted somehow, maybe not representative of what people really do. But I guess you can go to like the most popular open source projects that have a reputation for having good code quality, but then you may not have enough of them, right?
You're spot on. I think
You've thought about all of this before.
Yeah. I mean, not only me, and of course, the community has been wondering how the heck do we do this since quite a lot of time. GitHub stars can be not only gamed, but
you can pay for it. Even
you can pay for them, but also some projects, especially now in the Gen AI era, literally in the last 6 months, they go viral. They gain thousands of stars out of nowhere just because the project is cool. And nothing to say about the quality. It could be a very high quality code base, but most of the time it's also a very small code base. We've seen projects blasting through the amount of stars that PyTorch had or TensorFlow in literally like 2 weeks. And you can't really compare the quality of a code base that has been worked on by a very large community such as PyTorch versus like a small agent framework that has been built overnight. So that is one problem with stars. Of course, there is a certain level of static analysis you can do on code, all the way from running linters to running style checks. But the truth is, with modern IDEs, the vast majority of code that we push into a repo today has gone through several different linters and checkers. So that seems to be like really the low bar in terms of quality. And above that, yes, if you only want to filter for the very well-known projects, there are very few of them. So that code base is not enough to guarantee the quality.
So just like any area in AI or generative AI, there's risk, right? So there's, you still have all these items that fall under the umbrella of responsible AI. So which ones of these buckets are you most concerned about, right? So there's the ethics, security, privacy, safety, uh, and so on and so forth. So which of these buckets are you most focused on?
So first of all, I would say code overlaps with the same buckets as natural language. And I want to say that up front because oftentimes, and sometimes I maybe even fall into the trap myself. I thought, okay, how hurtful can be code compared to natural language? You're just writing down syntax and and weird constructs compared to writing down words. The truth is, within code, you can write comments and you can write strings. So if you want to prime a model to generate any kind of toxic or biased content, and there is no filter on the generated tokens, you will be getting pretty much the same negative results you get from a standard LLM. Because the truth is, the underlying model is exactly the same. So you can always prime it to generate bad content. So that means also that likely whoever is working on this problem in general is also finding solutions for code generation with LLMs. The additional problem, though, that we have in our specific vertical is the fact that, and this has been studied, by the way, already, I think also by GitHub Copilot, by means of allowing people to write code faster, it sorts of make developers complacent. So they spend maybe less time vetting the code, reviewing exactly what they're pushing to their GitHub repo. And it turns out that that allows them to introduce more bugs, maybe more security flaws.
Yeah.
I
So that's why listeners don't just accept the code that these things spit out. You still have to read it.
I agree. Yeah,
Right.
that's the main recommendation I give to everyone.
I mean,
say, hey,
just like you don't accept the paragraphs or sentences it produces without reading it, right? Same thing
yeah,
applies here. Yeah.
same as text. I agree. It's just harder, perhaps, to find those security flaws. It's easier to go through text and be careful, but bugs are sneaky in code. So if you have someone else writing code, you never know if it's you that didn't understand it or if there is actually a flaw or a bug in there. That's something that we will have to figure out how to fix with time. But yeah, it's a problem that we already have for sure.
So the one thing that I think in this space that would worry me if I were in it is just I guess this applies to general LLMs too. It's just kind of the unintended use, right? So it's basically now you're making developers and engineers more productive, but guess what? You're also making kind of hackers and black hats and kind of nefarious actors. You're giving them superpowers, right? So the script kiddies now can basically do a lot more than before, right?
Okay, I will probably have different answer compared to what I usually hear on the Twitter sphere. But this is my personal take. It's my podcast, so I'll go ahead with my opinion. I was in the early security community when I was a teenager. That's where I started to get my technical chops. And even back in the days, we were talking about script kiddies because older people were publishing frameworks and were giving you libraries that allow you to write exploits
Malware,
in a much easier way
runs.
compared to the past, right? So it's always a cat and mouse game. There is no way out of it. We're always building better tools that can be used in an amazing way that will have a beneficial impact for mankind, or they can also be used in the worst possible way. And I'm not saying let's pretend that we're not enabling more people to do bad things. But then at the same time, I also think we've been doing this for decades in software. And this is not way worse than it was in the past, to be fair. It's just that it multiplies the number of people. But I would say every year we multiply the number of developers in the world, regardless.
Or it's just that productivity increases in both sides of the security battle.
They do, right? Otherwise, nothing will be working in this world if you think about it, you know?
Right. So
Yeah,
the people who are writing exploits are now also more productive.
of course. Yeah, and
Right?
also the people that the white hackers, the white hats, they're way more productive than they were before. So I think we're gonna always strike a good balance between the two. At least that's my hope.
Yeah. And so what about I guess intellectual property, right? So this is an issue for let's set aside that it was trained on GitHub and people are upset about that, right? So and so on and so forth. Um now if you ask one of these LLMs to write something for you, you can go to another service which will check if it's plagiarized, right? So at some point I think all these services will have to just build that in, right? So don't produce
Agree.
anything that's plagiarized. So in the case of code, right? So what you don't want is for if you're in a company and then you're using one of these things, and then you start using that code and somehow you get sued by a competitor, right?
Yeah, we need to solve the provenance problem.
Yeah.
And it's a problem with LLMs in general. I think it's more important with code right now. We see already some solutions for that. For example, if you use Bard and you're asking to generate, a certain, amount of code, it usually gives you references to the GitHub project where that likely the model has been trained on. So that's a good starting point. GitHub has also a feature that allows, I think, to block code that comes from repos that don't contain code with certain licenses. So we're making baby steps towards the correct solution. I think copyright laws have been historically very hard to make progress on. Even when Google started, they kind of changed completely the copyright laws in the decade when they were having success. So I think Gen AI will bring also a sea of change for arts, for code, for text, and it's good that some of these lawsuits are going on already, because I don't see them as something that stifles innovation. I see them rather as necessary progress to have the discourse and figure out how do we make sure that people don't plagiarize and that whoever should take credits for intellectual property actually gets some level of even revenue share. To be fair, that's my dream scenario. If I'm an open source developer and I put something amazing out there, models are trained on that, and people find your code extremely useful, I would love if there was a way for you to get a cut for your intellectual contribution. We're not there yet, but I think that's one way to solve the Gen AI conundrum that we face today.
And to be fair, I think I kind of over inflated the problem in the sense that so in the case of writing, right? So it's clear if this one of these things produces a sentence or paragraph that's plagiarized, yeah, I mean that's a big deal. But in the case of code, I mean, if it produces a function or two that might have been plagiarized, it's a little harder to find if it's buried in a it's very different than an employee walking away from a company, downloading
With
code
a code
and
base,
then
of
going
course.
to another
Yeah,
company, right?
yeah,
So
yeah,
that's
yeah,
not
yeah.
what we're talking about here. We're talking in the equivalent of writing, in the scenario of writing a few sentences or a paragraph or two. It's
Yeah.
a lot harder and maybe less of a big deal in terms of the bigger picture, right? So
I agree also, because what is the definition of plagiarism in that case? There are a lot of coding patterns that are universal at this point. So you will find them in millions of repositories. So that's not really copying code. It's just borrowing patterns that everyone is using.
how big a problem is hallucination in the LLM for coding area, in the sense that I do notice that the public LLMs do hallucinate code. By hallucinate, I mean code that doesn't work.
Oh, absolutely. I mean,
You know?
LLMs hallucinate in general on
Yeah.
any
Yeah.
modality that they generate. I think on code, there are some key advantages, and that's the reason why I'm excited to work in this field. The fact that, for decades, we've built tools to analyze, test, even simply compile and run code. And that gives you a big advantage compared to checking if natural language is actually correct or not. So the issue with LLMs hallucinating is the fact that they do it with high confidence. You read the output of a GPT-4 writing a perfect fake news, unless you're an expert in that field and you don't spend a lot of time on routers checking if that maps are a reliable source, you will be fooled. With code, at least we have the advantage that, especially if you're on Replit, the LLM generates the code and you can try to run it. You're in an isolated environment. It's literally a container. You can even disable internet access and you see if it does what you expect. If it doesn't, you just toss it away. So that's the beauty, in my opinion, to work with code rather than natural language. They will still hallucinate for a while. We are far from having perfect models, but I'm more excited about code because of this capability of having a feedback.
So what are the key trends more broadly in AI that you're excited about, that you think will translate to what you're doing in focus on coding and software engineering?
I'm excited in general about the open source community around LLMs.
Okay.
I think we are making something amazing, not only in terms of training models, but all the ecosystem of tools that is blossoming around them. I'm talking about the LangChain, Llama Index, guardrails of the world, all these different toolkits that allow you to build end-to-end applications. That is the part that I'm currently most excited about. I do know that progress in LLMs will be done. There are large companies behind them. There are startups up and coming that are going to be putting a lot of effort and capital on the problem. But the reason why I was so excited about this open source movement happening in parallel is because a lot of people that are not AI PhDs or people are training models are still building amazing tools around it. And that makes us way more powerful as of today.
Yeah, I think we will need a next iteration of these tools that are much more enterprise grade, I would say. Right?
We are going to be seeing LLMs.
Because they're a bit more of a exploration tools. I mean, a lot of these libraries change every day. There's no way you would deploy them to production.
I agree. I mean, it's the nature of the fact that we started just a few months ago, but we got to start from somewhere, and I'm glad we already did.
What about just so? Do you follow any of these things around? I guess the open source models you're excited about, and I would suspect if you want a model that's so specific, in this case coding and software development, you may not need these ginormous models, right? So what it really comes down to data and saturation, right? So and so then that becomes much more tractable and much more possible for a startup like Replit, right?
Absolutely.
And so, but then, do you think that there's still a lot of things that we need to work on as a community around efficiency, right? So in terms of one of the things, the two things that still bug me are, one, cost, right? So for API calls and inference, and then latency. But then the thing that heartens me is, you look at the computer vision and speech community. I mean, they figured out how to deploy these things to doorbells, to phones, right? So I think we're still in the early days of compression, distillation, quantization. There's a lot of tricks that still need to be done to make these models a lot more efficient and faster and cheaper to deploy. Right now, I would imagine it's expensive every time someone makes an inference call or a prompt to one of these models, right? So
we're getting there. I totally agree with you. But if you think about it, speech to text on your smartphone, maybe 7+ years ago, was definitely going through a cloud provider.
Yeah.
And the translation was happening in the backend and you were getting back the text. As of today, these models are running local.
Offline, you can still use them. Yeah.
Yeah, they're completely on the edge, running on your like specialized SoC on your smartphone. So the reason why that happened is, of course, hardware is improving year over year. That goes without saying. But whenever a technology becomes so fundamentally useful, the industry pours a lot of money and smart people at the problem. And eventually we find ways to make it cheaper, to get better unit economics, and to make it faster. So I strongly believe that it's going to happen with LLMs as well. It's hard to predict the timeline because they are definitely a bigger and more complicated artifact compared to like a speech to text model. But we're going to get there. And I see already some early signs of that. There is, for instance, GGML, which started as a like grassroots open source project with basically like a one lead and a couple of people helping. And it just turned into a startup. It has a very flourishing community helping. And today you can run a Llama 2 on your MacBook M2, and it's freaking fast. You kind of get a small ChatGPT alternative running in local. So these are the first signs that we are definitely going there. They're not going to be running on your iPhone in 2024, but eventually we're going to find good ways to distill, leverage the specification of the models using mixture of experts. There is a long list of ingredients in the recipe that will make them more affordable, and we're going to get there.
So we've spent most of this episode talking about models and implicate data and the implications of both of them, but I think not as many people. I think more people should be talking or thinking a little bit more about UX, right? So in your case, as more and more people start writing code, is kind of the idea. Are development tools still the right approaches and paradigms, because they haven't been retaught in years, right? And also, if you have more people writing software from different backgrounds and different levels of expertise, what guardrails do you put, right? So in terms of making sure, because before, when everyone was kind of hardcore and geeky, right? So you trust that they would read the code and be careful and so on and so forth. So do you think that and then before they commit code and the version control tools and all of that, so there's a lot of things that can be revisited, you think, in terms of as more and more people participate in this kind of coding and software development?
The short answer is yes, they have to be revisited, and they will be revisited.
Yeah.
I can't say too much, as you can imagine, but if you go on our careers page, and please, for whoever is listening and they're excited about Replit, go and check it, because we're hiring and we're growing very much. You will not only find roles in AI, but you will also find a lot of job openings for design. And the reason is we're putting a lot of effort in trying to rethink the developer experience. I totally agree with you that a lot of assumptions that we had in the past decades will vanish because of AI. We have been seeing a glimpse of that with the code interpreter from OpenAI. A lot of people got excited about that, and I'm one of them. I think it's a very cool, creative way to rethink how we write software. And we are gonna be building, solutions like that and Replit, and even things that I can't really talk about today. But it will happen. And by the way, there are a lot of startups also that try to rethink a bit some parts of the software development lifecycle. So all the developers know that has to change as soon as possible. I agree.
Yeah, and I think just more broadly speaking, I think right now there's an overemphasis around models and fine tuning and training, but really there's a whole swath of people who need to be involved in building AI products and applications
There will be.
that need to be addressed, right? So that need to be brought in earlier on, and all the collaboration tools that we used to have that were developer centric, those have to be revisited, right?
If you think about it, it happens with every tech wave. Like we had smartphones, and at the beginning, all the craze was about better hardware, better displays, better CPUs. And then they've kind of been all the same in the past, 5+ years. And now all the effort is How do we rethink the applications? How do we rethink the UX? Same is happening now with Gen AI. The cool, shiny object that everyone wants to improve are the underlying models. It's very cool to train your model or poke the model and figure out what you can do. And then based on these like few years of exploratory work, we're gonna start to see way more application developers building on top of LLMs. I expect the progress there to slow down a bit on the LLM evolution. And as you said, most of the evolution will be on how do we build apps, how do we build on top of them. It's coming. If I can make a prediction, I think we are getting there.
And of course, I'll close this podcast by going back to models after I just poo-pooed models and training. So I guess one of the questions is are models going to be a differentiator for companies like Replit in the sense that there might be some other company who claims our model is better than Replit for this and that, and so is that going to be how development teams decide, you think, or is it much more of a offering around features, right? Because there's much more than the model. There's the collaboration tools, deployment, and so on and so forth. But right now, do you think kind of there's a lot of bragging rights around the quality of the model still?
There are. If you are on Twitter, I don't know you are, it's on a daily basis. The problem there is benchmarks, especially for code generation, are well known not to be reliable. There hasn't been enough effort on them compared to natural language benchmarks. So our philosophy is we don't try to obsess too much about them. Like we train our model, our Replit code V1, focus on code completion. And then, we also happen to benchmark it at the end out of curiosity to see how it performed, and it did pretty well. But definitely what we care about is we put it in production and we see how our users react. There are some metrics to measure, such as if you do code completion, you measure the acceptance rate of the completions you generate. And we just saw it blasting out the water, the previous model that we were using. And that was our victory. We care when users find it more. We care when it makes users more efficient. That's what we want. Then the benchmark raise, I think it's kind of pointless as of today. Benchmarks help to understand, to give an idea, am I going in the right direction or not? But all the bragging rights about them, maybe they're a bit too much. And I think over time we would see startups focusing more on, are we making our users happy? And that's how you build a successful product.
Actually, let me close with this. So how do users of these tools feel about IP in the following sense, right? So let's say I'm not saying this is happening right now, right? But given that I started my career in a hedge fund, right? So let's say I'm in a hedge fund, I'm using these tools to write code. How do I know that my code is not being used to improve a bigger model that other hedge funds can then benefit from?
That's a tough one.
Yeah.
The only thing you can do is make sure that your code base, of course, stays private and don't use any third-party models. So the reason why Copilot and ChatGPT are blocked in a lot of companies is to make sure that there is no data leakage from, like a hedge fund towards OpenAI. Now, I think every major LLM provider out there has terms of services, and they promise you that are not going to be training on the data they send around. So in principle, we should feel safe. In practice, I think companies that want to protect their IP will only use LLMs if they can run them on premises.
So this has been great. And again, reminder, Michele is going to be speaking at the AI conference, September 26 to 27 in San Francisco. Be there. I'm the program chair, outstanding program. Details at aiconference.com. And I may not have mentioned this to you, Michele, but one of the keynotes at the conference is Peter Norvig, who I specifically asked to talk about all these AI coding assistants because he's obviously super interested in this topic and has written a lot about it. So that will be a big treat for all of us.
Totally. Thank you, Ben. This has been a pleasure. Loved chatting with you.
Thank you.